Okay, welcome to JC Connect. In the previous class, we were discussing about some of the tests on concrete. Now, we'll move on to the tests on aggregate. Here, um, some of the very important aspects we'll try to cover. Of course, you already studied some of the tests as well as the properties. We'll try to revise it and we'll try to finish as early as possible. Okay. Um, First thing is that how the total quality management, how the total quality management to be established in case of maintaining maintaining the quality of the aggregate. Okay. Sometimes the question will be of in other way also. Uh, they may ask explain the different tests on aggregate. That is the first question. In other way, how the total quality management has to be established in uh, monitoring the quality of the aggregates. See, always you have to remember that is first one, the selection. So selection of the aggregates, that is the first thing. It is based on the purpose. Based on the purpose. Always you remember this. Okay. So what kind of aggregate you are selecting? Okay. We'll discuss that when it comes to the classification of the aggregates. What's the purpose? Where exactly you are applying it? Okay, that is the different thing. Okay, then quality aspects. Okay, what kind of quality? How exactly you are going to determine it? Okay, quality aspects in the sense that whether proper gradation is there or not. Okay, whenever, for example, if you are same aggregate, if you are using it for highway projects, the gradation is very important. Okay, so we have the MORPH specifications are there. Okay, according to the MORPH specifications only, I would go with the gradations depending on the type of the projects. Okay, then the third one is about the variation in the mixed proportion. That is also going to affect the indirect uh, quality of the aggregate. Suppose if assuming that you are designing for M20, then you should know how much quantity of aggregate has to be added at what gradation. Okay, the gradation of that, how exactly if proper mix design is there, so then there will not be any problem associated with the total quality management of the aggregate. Okay, somewhere in all any of these stages, somewhere if you are going, okay, definitely it is going to affect. Okay, then once the mix design is done, okay, during execution in the sense, so batching and mixing, how exactly it can be done in the field. See, most of the time you will give them M20 design, M30 design, M40 design, and M50 design, but the proper execution at the site, that is also very important. Okay, before this I was explaining about when the selection of the aggregate, even you can add the sampling also. Okay, you can add the sampling and bringing to the laboratory and testing, that is the that I already explained. So bringing the materials and testing the laboratories. Okay, that also you can add in this stage. Then once it is executed, once it is executed, supervision as well as the workmanship, that is also very important. You can call it as supervision as well as once after execution, workmanship. So till curing and period, at least the proper care has to be taken. That is one. Either if you are going with a mortar or if you are going with a concrete. Okay. So from starting first, including the sampling, then quality aspects, then mix design, execution, and supervision. Okay. If all the things are perfect, so then you can say that definitely you are achieving the standard expected quality in the site. Okay, sometimes they may ask the question in the other way: how exactly the total quality management aspects has to be satisfied onto the into the site with respect to the quality of the aggregate. Okay, they ask, you can give in this way: how exactly the selection can be done, what exactly the quality aspects, so mix design, so execution, batching and mixing, so then supervision and the workmanship. So that is also a very important aspects. Okay, only mixing and if supervision is not there, then there will be a problem associated with the supervision. So starting in the project management project management, these all aspects play a very important role. Okay, so then we slowly will move on to how exactly which are the tests on the aggregate and which are the classifications of the aggregate a little bit faster. Okay, so of course this aggregate is a pillar with binding material. Okay, derived from rock, and is a form of the body of the concrete that reduce the shrinkage and affect the economy, then occupies almost 70 to 80% of the volume. Okay, and have considerable influence on the properties of the concrete. Important to obtain the good quality of the aggregate also. What we are talking about in the previous slide, that is, it is very important to obtain the good quality of the aggregate with the proper gradation, and it is not chemically inert. Okay, chemically inert in the sense there will not be any reactions. Okay, even sand is also chemically inert. Okay, reactions will not happen. For example, aggregate, if it is there, then if you mix with the concrete, it will remain the same. It will occupy the volume. Okay, it will not change in one form to other form. For example, if sand is there, sand will remain the same. If aggregate is there, aggregate will remain the same. It will not change to some other called some other rocks. Okay, means it does not change, or not, no reactions are going to happen in between the aggregates. Okay, so normally the bonding is going to happen between the sand, the cement, and the aggregate. Okay, so aggregate um, always combine with the binding material, that is cement, and forms the either it is a mortar or it will be a concrete. Okay, so it is almost what I said is that in the above it is providing volumetric stability and the durability. So then, based on the classification, so it is broad classifications, two categories. So one is the fine aggregate and the coarse aggregate. The fine aggregate is um, greater than 0.07 mm. You can say this one, you can write it as greater than 0.075 mm or 75 micron. So above 75 micron and passing through 4.75 mm. Okay, or you can retain on 0.05 mm or 75 micron. Okay, passing through 4.75 mm. So normally that we can call it as a fine aggregate. So below this, okay, even if it is passing uh, through 75 micron, so we can call it as silt. Okay, if it is passing, it is a full powder only. 75 micron means is the least C we can observe. Okay, in the soil classification. Okay, fine aggregate normally we can call it as a sand. Is the best example. Then coarse aggregate, it is retained on 4.75 mm sieve and lesser than 80 mm. Okay, again here also you have different gradations will be there. So exactly it will be done. And one very important thing always you have to remember is fine aggregate is having always the surface area is more, surface area is more, and coarse aggregate is surface area is less. So this I have extensively discussed with the as the size of the particle is gone decreasing. Okay, the area will increase. Specific surface area will increase. Okay, don't be under the impression that the coarse aggregate is bigger, so surface area is bigger. Not like that. Okay, so always it is okay meter square per gram. Okay, if you take per gram, how much surface area you are getting. Okay, always the unit I already said that it is meter square per gram or meter square per kg. It will be there. Okay, that always you have to remember. Okay, so this is standardized classification. So then you can see the different types of aggregates with proportions for aggregates. So then um, some more classifications based on the origin. So it is natural and artificial. So then on the basis of size, all in aggregate and graded. All in means it is a mixed. Okay, all in means it is a mixed proportion of aggregates will be there. But graded, so specifically they will mention 20 mm size or 10 mm size or 15 mm size. So different sizes with the proportions it will be there. Okay, it's a gradation. Okay, then angular and flaky. Then on the basis of the unit weight is normal, heavy, and light aggregates. Okay, based on the specific gravity, or it is the unit weight or the density. Okay, so based on that, we are going to classify the normal, heavy, and light. Okay, so when it comes to the natural aggregates, so it is obtained by crushing of the rocks. So it is going to happen with the help of the weathering action as well as the natural agencies of the rocks. So it is most widely used uh, are igneous rocks. Okay, then artificial aggregates. So broken bricks. So some of the brick beds suitable for mass concreting and foundations that can only for the foundations you can use it. Okay, then a blast furnace slag. What is this blast furnace slag? Blast furnace slag always the slag is a industrial byproduct. Any industrial byproduct. It is the industrial broad product. So if it is a phosphorus slag, so it is derived from the phosphorus industry. If it is a iron slag it is from the iron and steel industry. Okay, if it is a for example any other sulfur slag. So it is derived from the sulfur based industry. But blast furnace slag, okay, it is um, derived from the iron industry only. See, in the iron industry, what will happen is that uh, normally iron ore will be extracted, or iron ore will be um, um, is the raw product, raw material. Iron ore is a raw material. So during the separation of the iron ore um, in blast furnace slag, blast furnace, blast furnace, the iron ore will be brought from the site. Then it has to be separated. During the separation process, the slag is going to generate in blast furnace. So it itself is having a different sizes. Okay, that can be used as an um, aggregates. Of course, it is a the size will be varying from say roughly around it will be from 10 to 30 That much size it will be there. Okay, sometimes this iron ore that can be made into fine aggregates. Okay, then it can be used as a fine aggregates also. Okay, then these are all fire resistance because it's already burnt product. Okay, then synthetic aggregates, they are thermally processed materials such as expanded by clay and shale. So these are all lightweight aggregates. The density is very less. To say if you say it is a density is very less for synthetic aggregate. Then all in aggregate, it is different fractions of fine and coarse sizes. So they are not recommended by the quality of the concrete. Very important. We need we need gradation. So gradation play a very important role in maintaining the total quality management of the aggregates. Remember this. The proper gradation is there, if the proper gradation fractions is there, so definitely the strength of any of the material is going to increase, or strength of the concrete or strength of the mortar, it is definitely it's going to increase, irrespective of either it is the aggregate, or it is a coarse aggregate, or it is a fine aggregate. Even the fine aggregate, if you are maintaining the proper gradation, so uh, that play a very important role. Okay, so when it comes to the graded aggregate, so aggregate most of which passes through a particular size sieve, graded aggregate. So graded aggregate of normal size 20 means the aggregate of which passes IS sieve of 20 Okay, this you have to remember, that is passing through 20 Okay, then shape, it is elongated aggregate. Its length is almost 1.8 times, or 9/5 of its mean dimensions, average dimensions. If you take the average of all the dimensions, it is the length will be 1.8 times. Okay. Then flaky, so lateral dimensions should be less than zero point 0.6 times, or 3/5 of the mean dimensions. So orient in one plane with water and air voids underneath. Um, Adversely affect the durability as well, and it is restricted to maximum of 50% durability. So you can see here, it is flaky as well as elongated. You can see the length is more, it's 1.8 times the mean dimensions. Okay, then flaky aggregates. So then, what exactly the good quality of an ideal aggregate? Okay, so an ideal aggregate used for the manufacturing of concrete mortar should meet the following requirements. First one, should consist of natural stones, gravels, sand in various combinations of these materials. Should be hard, strong and durable. Should be dense, clear and free from any of the coatings. Okay, no coating should be there. Should be free from injurious of vegetable matters. Means um, organic matter should not be there. Organic matter should not be there. Means any biodegradable part should not be deposited on the aggregates. Okay, should not be contain flaky and elongated bases. Should not contain any um, material liable to attack steel reinforcement in case of reinforcement of the concrete. Okay, like chlorides attack, sulfate attacks. We already discussed that. Okay, if that much chloride content is deposited on the surface, so definitely it is going to affect the reinforcement, because chloride attack, um, chloride versus iron. Okay, the reaction will be very faster. Okay. So then, characteristics of aggregates. Okay, the aggregates containing the constituents which generally reacts with alkalis in cement cause excessive expansion, cracking of the concrete mix should never be used. Okay, suitability of aggregate should be judged either by study its service history or by laboratory test. So always the pilot scale test has to be carried out, or you can do the um, in the laboratory with the help of a proper mix design and conduct it. Okay. This very important. This aggregates containing the constituents which generally reacts with the alkalis in cement. What will happen is that one very important alkali, that is NaOH, sodium hydroxide. Uh, See, it is required because in a geopolymer concrete, it is being used. Okay, but uh, with the proper proportions they are using it. With the proper proportions they are using it. Okay, now it is been famous. Hmm? Normally, sodium hydroxide play a very important role in geopolymer concrete. So he said that generally it goes the excessive expansion. How exactly it is going to happen? You take NaOH, you take NaOH, and you just add that to a 1 liter of water. Simply 1 liter of water. So you can feel that the heat is going to generate suddenly. um, um, Heat is going to generate means that it is exothermic reactions. Exothermic reactions means heat is released. Okay, the heat is released. Even if you add more sodium hydroxide to 1 liter, see, a lot of difference is there. You take one example. If you take 10 grams of sodium hydroxide and dissolve it in 1 liter, so you can feel temperature is roughly around increase of 50-55 degrees centigrade. But similarly, if you add 1 kg of to 1 liter of water, so even you cannot touch it. Okay, it always start boiling. Okay, always start boiling means the oral concept in this is that, so if you add um, alkali uh, to the uh, concrete mixture, so suddenly there will be an expansion is going to happen due to the increase in the temperature of this alkali. Okay, suddenly the water temperature roughly around 70 to 80 degrees centigrade. Once it is boiling, it will start boiling means slowly the expansion is going to happen. So whenever you're adding sodium hydroxide, remember that it has to be properly designed, or proper mix design has to be made. Okay, temperature should not be increased because it will be under temperature stresses. Yep, that has to be taken care. So then the size and shape of the aggregate particles mainly influence the quantity of the cement required in concrete mix, ultimately the economy of the concrete. Remember this. Okay. It is definitely because um, first one is when it comes to the economy, it is cement more costlier, sand than aggregate. And as for our understandings, so definitely it is going to occupy in the concrete 70 to 80% of the volume. So with this subjective, we can say that it's playing very important role. If something has happened with this or if proper gradation, if we are not maintaining, so it is affecting to the cement and it's affecting the sand. Okay, so that has to be taken care. Okay, for the preparation of the economical concrete, one should use large core size visible for the structure. Okay, then for normally for concrete works for dams and retaining walls, this is preferred. Okay, RCC or beams columns 20 mm, flooring 10 mm is preferred. Of course, it depends. Um, you can go with some proper mix design and you can use in place of 20 and 10, and you can do that. But these are normally preferred. Okay, RCC works you can use 20 mm also, not a problem. You can use 20 mm, but in what proportion you are using that has to be clear. Okay, then strength, the sum of the properties that include strength, particle shape, specific gravity, bulk density, voids, porosity, moisture content. So strength, so it should be equal to that concrete. Okay, the rocks commonly used as aggregate have a higher compressive strength. This is remember. Okay, it gives the more compressive strength. So then always you have to conduct uh, 10 percentage fineness test. Okay, means uh, 10 percentage fineness test means during crushing. Okay, during after crushing, um, the overall, for example, if you take um, the 1 kg of the aggregates, so after crushing, okay, 10% of the fine size is it has to be given. Okay, that we'll discuss. It is the ratio of that fine, how much fine it has happened, 10%. That will comes as a 10%. The ratio should be 10%. Should be 10%. So here it's a 1 kg. For example, if you are crushing 1 kg of aggregate, it will be in the denominator aggregate. And after crushing, how much it has to come here. So 10% fineness has to be, that test has to be conducted. Okay. So then we'll discuss that how exactly it is going to come. So cresting test is more reliable because the compressive strength, so toughness by impact test and hardness by abrasion test. Okay, shape and texture. So shape influences on the properties of the fresh concrete um, more than the hardened concrete. So flaky aggregates requires more cement paste, produces maximum voids. So angular shape is the best, and the shape and texture govern the water requirements. Okay. The remaining things we will uh, have a discussion tomorrow, and we'll try to cover uh, some of the things. Okay.